All right, everyone. Your notes today are going to be on average atomic mass. We've already talked before about what the average atomic mass is an average of. Do you remember the vocabulary word that I'm looking for? Hook me up. Isotopes, that's correct. Average atomic mass is an average of these things called isotopes. Isotopes are atoms of the same element that have a different number of, do you remember? Neutrons. Okay. If they have a different number of neutrons in the nucleus, what does that mean is actually changing? It's not the number of protons, right? We're changing neutrons, but what also is changing about the atom itself? And this is a vocab word. The nucleus size does change a little bit, but what also changes, because you're adding more particles to that nucleus, I don't like the word atomic mass. Do you remember? Mass number, that's right. All right, so when you increase the number of neutrons, technically what you're doing is you're increasing the mass number. Increase the mass number. Okay, so what I have for you today is a formula that is going to help you to actually visualize how we calculate an atom's atomic mass, average atomic mass. So for example, let's pretend that we are looking at hydrogen, and we already talked about how hydrogen has 3 different isotopes, correct? Okay. Well, there's hydrogen 1, hydrogen 2, and hydrogen 3. Each of these atoms have a different mass, and the mass number is revealed here with a 1, a 2, or a 3. Now if we look at the average atomic mass of hydrogen on the periodic table, it'll look like this. And it's in a decimal form. And the average atomic mass is really close to 1, so which one of these isotopes must be the most abundant? That's right, hydrogen 1. Alright, so let's see if we can pull up some real factual data about the relative abundance of each of these elements, because each of these elements have their own individual abundance, and that abundance is going to appear to you as a percentage. Okay, so we already know that hydrogen 1 must be the most abundant isotope of hydrogen, right? So let me pull up some information here. Hold on. Okay, because I'm going to use actual real information to help you. Okay, here we go. So the isotopic mass of hydrogen 1 is slightly over 1, and that's because protons and neutrons actually have a mass that's a little higher than 1. And we're going to put a unit on these masses. Alright, you ready? So hydrogen 1, its real mass is 1.007825. Hold on. 1.007825, and then we're going to add a unit. And you know that atoms are super tiny, right? So we have to use a really special unit when we're talking about its mass. It's called atomic mass units. And we'll talk about what an atomic mass unit is in just a second. So now let's look at hydrogen 2. Hydrogen 2's isotopic mass is 2.01410. 2.01410. How many sig figs do I need there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. One more. 1. And again, that unit is atomic mass units. And now let's check out hydrogen 3. 3.016 049. Do I have enough digits there? I think I did 6 on all of those. 6 decimals. Am I good? Alright. Alright, well, now what we need to look at is something called the relative abundance. And the relative abundance, like I said, is going to appear to you as a percentage. So we already know that hydrogen 1 must be the most abundant isotope of hydrogen. But let me give you the number. You ready? It is 99.9885% abundant. 99.9885% abundant. Really close to 100%, huh? Almost all the hydrogen you will ever encounter in your lifetime will probably be hydrogen 1. So let's check out hydrogen 2 now. This one must be really small, must be less than 1%, right? Okay, so we already know that it's less than 1%. 0.0115%. Okay. And then hydrogen 3, I'm looking at a reference table here. It is so low that they call it a trace. In other words, it's almost negligible. Do you know what that word means? Negligible? Ignorable. You can ignore it, yeah. Alright, so really the two most common isotopes are hydrogen 2 and hydrogen 1. Now, you want to see how we get that average atomic mass? Because there's a formula. And here's what it looks like. So the average atomic mass for any element is going to be equal to, you see my big fat bracket? You're going to need that. Okay. You're going to take the percent abundance for the first isotope. So notice I'm going to put a little sub 1. That sub 1 means that we're talking about the first isotope. Take that percentage, and we have to change it into a decimal form. So how do you change a percentage into a decimal form? Yeah, divide by 100. Okay. And then you need to multiply by the isotope's mass. And which isotope are we talking about? We're talking about isotope 1. So you see how I'm doing another sub 1. And there is your first isotope. That's all the math that you have to do for the first isotope. You have to do this for each isotope that you have. And then here's the best part. You don't divide, like to find an average, you don't divide by 2. You're not going to do that because guess what you've got? You've got percents. There's no dividing at the end. That's the most common mistake that students make, is they divide by 2 at the end. No, you don't need to do that. You ready? You add. So I'm going to start abbreviating percent abundance 2 divided by 100 to change it to a decimal. And then you multiply it by the mass of the isotope. Oh, I didn't put mass here. The mass of isotope 2. There you go. And you do that for each isotope as many times as you need. Alright, you want to see an example? Don't you have enough information right up here to start filling in? Let's try it. You're going to need your calculator, okay? Good job. So, let me show you what the work will look like. obviously I'm going to talk to you about sig figs, right? But let me just show you the work. There you go. Here's your formula. Okay, so take them in and on your calculator. And I love using parentheses on my scientific calculator so that I don't have to do this in a bunch of steps. That's a little tip. Okay, you ready? This is what my calculator says, and we'll talk about sig figs. 1.0079 407 22. Alright, so let's start looking at some sig figs here and see what you guys think, okay? How many sig figs does this number on the top have? 6? 1, 2, 3, 4. Yeah. This guy's got 6. How many here? 7. Very good. What about this percentage right here? 1, 2, 3 zeros in the front. Don't count. 3. And what about this guy back here? 1, 2, 3, 4, 5, 6. I think it's 7. Alright, so you are multiplying, dividing, but you're also adding and subtracting. Whenever you have that combination, always go with the multiplying, dividing rule. Okay, that's just, it covers your bases, okay? So even though we're adding here, all I want you to do is worry about the multiply, divide rule, which is always the least number of sig figs. So technically, how many sig figs should we be reporting for this particular answer? Hook me up. Yeah, isn't that amazing? So hold on. 1, 2, 3. Do you need to round up? Yeah. Okay, so let's round that up. Technically, this would be 1.01. And what do you think the unit is for this average atomic mass? AMU. So look at your periodic table. Look back at the average atomic mass that they reported for hydrogen right here. 1.00794. Correct? So do you think that we did a fairly good job with our math? Yeah, sure we did. Yeah. Now there's some more, obviously scientists are able to do much more accurate work with their numbers, and so their sig figs can change. But for us, I think we did a pretty good job. That's correct. It rounds to 1.01. Alright, can I show you guys, if you have your homework, go ahead and pull that out. I want you to look behind the lab. So you should have in front of you the M&MEM lab. I'd like you to flip that open to the average atomic mass worksheet for me, please. Okay? Alright, to better understand how to do your homework, you're going to need to do the M&MEM lab first. So, you know how I gave you over here, I gave you these masses, these were tabulated for you, like I just gave those to you. But you see how also you have this thing called a mass number? For your worksheet, for simplification purposes, I allow you to use the mass number. Alright? So that's just word to the wise on the worksheet. You're going to be using mass numbers, but for real, like if you're talking about real science, you need to know that isotopes actually have a decimal form for their mass. But for simplification, for your homework, I'm allowing you to use something else called mass number. Alright, ladies and gentlemen, at this point, I think you've got enough notes written down, and the lab is self-explanatory. make sure that you sweep up any messes that you make with the M&Ms. If you have a food allergy to nuts, don't eat them. And don't ever weigh the M&Ms directly on the scale. You have a weigh boat. In fact, you have 3 weigh boats, because in the lab you have 3 isotopes. You ready for your isotopes? Here they are. We have mini M&Ms. Yeah. You've got plain M&Ms. And then I got almond M&Ms. Alright, so you just need to change that on your lab. Okay? Alright, so don't ever weigh the M&Ms directly on the scale. Is that clear, everyone? Alright, whenever you are ready to begin this activity, you are going to meet me over in the lab area over here, and I will give you a supply. You guys work in teams of 2. That's it.